Okay, friends, here is 1.4. Can you identify and define subsets of lines and planes? There's a lot of definitions in this section, and they are definitions that are pretty precise. So hang in there. Remember, after the lesson, when you listen to it, fill out your TRF, and if there's any questions, make sure you put them down on your TRF. All right, so the first definition we're going to talk about is a half line. A half line is a subset of a line consisting of all the points on, a given side. I love doing this because I see all my typos. A given side of a point on the line, denoted open circle with an arrow over top. Okay, so this is a half line. This would mean, here's my line. It's, let's say, A, B, and that would be, this is if I'm talking about the half line, starting at point A and going indefinitely toward B, it would go that way. Now, because it's an open circle, it does not include the point A. The point A is technically the halfway point. So it does not include the point A. Which brings me to my next definition, ray. Ray is the union of the half line and its origin. So in this case, it's that same line, A and B, but this includes the point A and goes that direction. If this looks familiar, it's because, remember, in algebra, when we're doing greater than, less than, graphing with numbers, it would be like the first half line does not include, so it would be greater, all points greater than A. The ray includes A, so it's all points greater than or equal to A. Between. The point P is between R and S. This is the notation I really need you to understand. When we say R dash P dash S, it means P is between R and S. And they are collinear. That means the ray from PR, going this direction from P to R, and the intersection of the ray P to S is this equal, the intersection is this point right here, P. Okay, because P is between them. All of these points on this side belong to the set that is ray PS. All these points on this side belong to the ray that is PR. But the intersection, since they both include P, is their intersection. That's just the element P. Okay? So let's look at a little bit more. Let's look at a postulate. Remember, once again, postulates are things we take as truth, but they're not proven. Postulate. Every point on a line divides the line into three disjoint sets: the point and the two halves. Okay, so let's look at example 1 with this one. Example 1 says, show that R is not between P and S. Show that R is not between P and S. So if we're looking at the two rays that we were talking about, ray RP and ray RS, if we wanted to look at their intersection, R should be their intersection point, right? Because that's the definition of between. It means R should be in between those. Well, if I kind of take my highlighter here and I look at this, we've got ray RP, which goes this direction, and then we have ray RS, which goes this direction. The intersection point is not just R. The intersection point is everything. from R through infinity. Okay, so that's the intersection point. The intersection point is ray RS. Okay? All right. If we had a separate point on this side over here, and we were going to maybe call it Q, and if we changed this problem, we could show that R is between S and Q. Now, please understand that between does not mean midpoint. Some students get that confused. Between just means it's sitting somewhere in between those two other points. All right, some more definitions. I know. Some more definitions. Opposite rays. Some of the things we were talking about earlier are opposite rays. Okay, here's my number line. Rays PR and PS are opposite rays if P is between. So here's PR, here's PS. Because of that, P is the intersection of those two rays, so therefore P is between R and S, and therefore PR ray and PS ray are opposite, meaning they're going in opposite directions. Next definition is segment. A segment consists of 2 points and all the points in between them. This is important. You're going to see this all the time. Segment RS is written as RS with a line above it, no arrows. Double arrows mean line, single arrows means ray, no arrows is a segment. Symbolically, segment RS is equal to the point R, the point S, and the value of X, all the values of X that are between R and S. Okay, so if I draw a line here, let me draw my line. Here's my line RS. And if I were talking just about segment RS, it would be this part of the line. R, all the numbers in between, and S. All right, example number 2 says, determine whether each statement is true or false. Ray CD and ray CD and half line CA's intersection point is C. Is that true or false? Now, this right here, half line CA does not include point C. So this is false. Okay, that's false. Ray CD and half line CA union is the line AE. Well, let's draw on this. Let's look at this. Ray CD looks like it goes from here over and keeps going, because remember, rays keep going. Half line CA, okay, that's an open circle and goes that way. Their union, all of them together, is the entire line. Yeah, it is. Because if you look right here, that kind of point right there fills in that empty circle, and the arrows extend the entire line. So yes, true. That statement is true. Okay, and last but not least, C. I'm going to kind of erase this right here so I can beyond this guy a little bit. There we go. Ray BC, okay, I'm going to draw this out. Ray BC, okay. Intersection with ray ED. Now remember, the way the ray is red is where the tail starts, going all the way through to the infinity tip. So since this is ray ED, it starts here and goes this direction. Okay, so the intersection of that is equal to segment EB. So now, again, this is the intersection where they intersect. Think back to algebra, right? This is where I was saying, where's your solution set, right? Your solution set, what's in common? is everything right here. So yeah, the intersection is segment EB. That's a true statement. Okay? Okay, so let's move on to another postulate. This is the plane separation postulate. This postulate says that every line in a plane divides the plane into 3 disjoint sets, the line and 2 half planes. This is hard to understand, but easy to see. So if we look at this picture over here, here is my line. This postulate says that every line, and that we'll call line P, divides the plane into 3 disjoint sets. The line, which is in red, so I'm going to put that right here, and I'll write the word line. And then we'll color the different sides. So this half, which is half H2, okay, so that's H2, H2. And then the other half is going to be the half H1, which I'll color in green. Okay, so 3 disjoint sets, the line, half 1 and half 2. Okay, so that brings us to the definition of half plane. A half plane is a subset of a plane containing all the points on a given side of a line in the plane. It does not include the points on the line, just the points on the side of the line. An edge and a half plane's, I love my typos, a half plane's edge is the line separating the plane into 2 half planes. Okay, so that line M right there is the plane's edge. Opposite half planes are the 2 half planes within a plane separated by the edge. So the opposite half planes are H1 and H2. These all make sense, hopefully. Angle, here's your big definition, one of your big definitions starting here. Angle. An angle is the union of 2 distinct rays with a common end point. Angle ABC is equal to the union of ray BA and ray BC. Okay? Sides. The sides of an angle are the 2 rays that form the angle. Okay? And last but not least, vertex. The vertex of an angle is the common endpoint or origin of the rays. This shouldn't be new to you. Maybe the terminology is new, but I need you to get comfortable with that terminology. Okay, please understand. Also, let's review real quick, or let's make sure we remember how to name angles. I don't know if this is something you have done before, but I want to just review it with you. This angle right here is named angle ABC. It can also be named angle CBA. Those are your 2 choices for the names of that angle. The vertex of the angle always falls within the middle of the angle's name. That way we know if it's multiple angles, such as something like this, and we have like a triangle like this. If it's something like this, and I'm saying angle ABC, I know I'm talking about this angle right here. Because if you had said something like angle BAC, that would mean I'm talking about this angle. So make sure you remember and you understand that the vertex is in the middle of the angle's name. All right, last 2 definitions. I told you there were a lot in this one. Interior of an angle. The interior of the angle is the intersection of the 2 half planes determined by the sides of the angle and containing points from the other side of the angle. Oh, what? All right, all it is, the interior of the angle is everything inside. All the points in between the points on either ray. The exterior of the angle is the complement of that. So it's all of this stuff on the outside. That's the exterior of the angle. I think I mixed those two pictures up. So look, whoop, whoop, whoop. All right, that would make more sense. That's all right. I'll switch them in your notes before you get them. All right, so those are your last two definitions. So let's take our definitions and apply them to this example. Example number 3, use the figure to list all other acceptable names for each angle. All right, so here's angle YWZ. I like to highlight them, YWZ. There's my angle. What else can I name angle YWZ? Well, I can name it angle ZWY. And that would be the exact same thing. Or I can also name it angle 2. That little number inside, sometimes we'll use that number to refer to the angle. All right, so look at B. B says rename angle 1. Well, angle 1 is this one right here. Well, I have two possible names for that angle right there. It could be angle XWY or angle YWX. Once again, noticing W is my vertex, so it's in the middle. C says rename angle ZWX. ZWX. Well, the only rename for that I have is angle XWZ. Now, I do want you to understand we can't use, I'm just going to kind of write this down here. We cannot use angle W as a name. Because if we just use angle W as a name, it's confusing. Are we talking about angle 1 or angle 2 or the whole angle W? Okay, we can't use that. The only time we can just name it as angle W is if that's the only angle sitting there. Okay, if it's the only angle sitting there. So for example, if we had a triangle and it was triangle A, B, C. Now I can say angle A because there's no confusion. But if my problem extended like this, now I cannot use angle A because I have two different angle A's. I have this part of angle A and I have this part of angle A. So always use, for now, use 3 letters. It's going to make your life easier when you get to the point where you can actually use 1 letter. But we have to be specific. The one thing about geometry is I have to know what you're talking about. And if you just say angle W or angle A, I don't know what you're talking about. All right, tomorrow in class we will work through 1 through 25 odd and do some TRFs and foldables and things like that. So please make sure you have listened to this lesson and have filled out your TRF with any questions you might need to bring to class.